Okay, so let's quickly go over some common sets we use in mathematics, and then I'll show you some basic example, which is not easy. It's basic, but not easy. So n is the set of natural numbers, 1, 2, 3, 4, etc. The positive integers, where the integers are the integers, 0, 1, 2, -1, -2, -3, etc. Q is the set of rational numbers. So it's all numbers of the form A over B such that A and B are integers and B is not zero. R is the set of real numbers, which can be thought of as the real line. All the numbers that we have here in the real line, for example, E, pi, square root of 2, these all are real numbers which are not rational numbers. Of course, the sets contain each other. The natural numbers are contained in the integers, they are contained in the rational numbers, that are contained in the real numbers, the set of real numbers. Every rational number is a real number. The irrational numbers are the set of real numbers which are not rational. So this is a set, a subtraction of sets. So we have natural, integer, rational, real numbers, irrational numbers, and the set of complex numbers. So a complex number is of the form a plus bi, where a and b are real numbers, and the I is an imaginary, an abstract number, which is defined here. I is the number that if we multiply it by itself, we will get -1. So these are the sets of common set numbers we use in mathematics. Let's see a basic example. So this is not the basic example. Okay. Show that there exists two irrational numbers, P and Q in R, such that, so these numbers are real. P and Q are real, but they are not rational. So there exist two irrational numbers such that P to the Q is rational. So P and Q are not rational, but P to the Q is rational. And we can assume that square root of 2 is not a rational number. So let's prove it. So we have one irrational number, square root of 2, that is given to us in this exercise. So square root of 2 is irrational. What about, so can I take P to be square root of 2 and Q to be square root of 2? Will square root of 2 to the square root of 2 give me a rational number? So I don't know this. Is square root of 2 to the square root of 2 rational? We don't know this. So we have to split our proof to two cases. Case 1, assume the square root of 2 to the square root of 2 is rational. In this case, we are done. We have found two numbers. Then take P to be square root of 2, Q to be square root of 2, and we have found two numbers, two irrational numbers, P and Q, such that P to the q is rational. P is not rational, q is not rational, but p to the q is rational. So in case 1, if we can assume that this is rational, we are done. Case 2, assume square root of 2. The square root of 2 is not rational. In this case, we can not say we're done, but we have found another irrational number. So in this case, take p to be square root of 2 to the square root of 2, and q to be square root of 2. Then what will p to the q be? So it will get square root of 2 to the square root of 2 to the square root of 2, which is equal to square root of 2 to the square root of 2 times square root of 2, which is equal to square root of 2 to the square of square root of 2, which is equal to 2, which is 2 over 1. So it is indeed rational. So in either cases, we have managed to prove that there exist two irrational numbers such that p to the power of q is rational. Off the record, I can tell you that case 2 is the true one. This number is indeed irrational, but proving that is harder than what we did here, and we don't need it. We don't need to find the two numbers such that p to the q is rational. We just need to prove that there are two numbers like this.